Okay, now we're going to look at some density examples. So as we see these two cubes here, we're going to notice that they're taking up the same volume, okay? So their volumes are equal, but their mass is different. So you need to write that down. And as you see these, you can see this. So that means that it makes their density different. Okay. So you need to write down these two cubes. Notice they take up the same amount of space, okay? But you notice that there's more matter in the one on the left, okay? So then that makes its mass different. And since the mass is different, that's going to make our density different, okay? All right, you can see that the one on the left has a greater amount of matter than the one on the right. So that means that the one on the left has the greater density of these two cubes. Okay, so this is a good triangle. Mainly, we'll be working with density equals mass divided by volume. But sometimes you'll see a question that asks you where it gives you the density and the mass and may try to ask you to find the volume, okay? So if you can remember this triangle, okay, and kind of where everything is, then that will give you the formula that you need to use. Okay, so from this triangle, we can get that density equals mass divided by volume. We can also get that mass equals density times volume. We can also get that volume equals mass divided by density. And I'll go over this more so in class. I just wanted you to see it here on your notes. Okay, so let's do an example problem. Okay, and it says, what is the density of an object with a mass of 60 grams and a volume of 2 centimeters cubed? Okay, so density equals, we're just going to use the basic one, mass divided by volume. Okay, so now all you need to do is locate these two things in your sample problem and plug them in. So let's do that. Okay, then you need to be writing this down as well. Okay, you can see that I've highlighted the mass there so that you can see it, and then I write it down. It's 60 grams, okay? And now I highlight the volume, and I put it in there, okay, which is 2 centimeters cubed. Okay, so now I have it written down. Now I'm going to do the math. So I take 2 into 60. I do this math, and that gives me 30. Okay, now we're not done because we haven't given a unit yet. Where do you get your units from? This is not hard. Look, watch this. Go over here. That was grams divided by centimeters cubed. Guess what I write down? Grams divided by centimeters cubed, and you circle it. Okay, so there's example problem number 1. Let's go through one more. Okay, example problem number 2. What is the density of an object with a mass of 120 grams and a volume of 2 grams per milliliter? Okay, now I messed up in just a second, and I'll have you mark it out. That should have been just 2 milliliters. Sorry. That's what happens when you're in a hurry. Okay, density equals mass divided by volume. Okay, and like I said, the majority of the time, they'll actually give you the formula that you need to use. Okay, so I pick out the mass. I write it down here beside the mass. Then I highlight my volume. Now, here's where I realized, wait a minute, that's not a volume. I gave you a density. So I want you on your fun sheet to mark out the grams, okay, because volume is either given to us in centimeters cubed or milliliters. And we'll actually work with this in class, and you'll find out milliliters is when you do water displacement, and when we have a regular shaped object, we'll use a meter stick or a ruler to find it in centimeters cubed, okay? So this one's in milliliters, so this would have been something like a rock that we use for water displacement. Okay, so we're going to go ahead and write that down, 2 milliliters. We're going to do the math. So it's 2 into 120. When I work that out, 2 will go into 12 6 times. 2 will not go into 0, 0. 2 times 0, 0. Your answer is 60. Now, the one thing we forgot, however, is what? Our units. You must put units. And it's not hard to do, guys. All you do is copy it over from what you divided from, okay? So the unit should read 60 grams / milliliters, okay? Because we divided grams by milliliters. That's the reason why we put the slash. The slash actually means divided by, okay? All right, guys, and circle it. Okay, this is the end of your density fun videos.